in a box of 50 potato chip bags, two will be underweight. I don't know if this actually does happen, but I know people always complain about the amount of air in your potato chip bag or your cereal box. Well, it's sold by weight, right? Not like number of chips or volume. So it's supposed to add up. Who audits this anyway? How do you know you're not getting ripped off? Anybody weighed it? You got a chocolate bar, it says like 65 grams. Does anyone weigh it to see it's actually 65 grams? Or can you sue them? Something they do in America. Anyway, in a box of 50 potato chip bags, right? That's how they come in boxes, so they don't get crushed. Two will be underweight. If you pick two bags of chips at random, from this box, okay, one, then another, or maybe two at the same time, determine the probability that both are underweight Does that seem likely? You got an idea how to kind of do that mathematically? Well, the first one, you know you got a 2 in 50 chance, and then the second one, well, should be even less than that, right, when you multiply them? What else could happen? You might be really, really, really unlucky and get both underweight. There's another couple of possibilities, aren't they? Determine the probability that neither are underweight. And C, well, what's your other only option? One is and one isn't, right? So determine the probability that only one is underweight. Okay. So I think you guys kind of know what you'd do, but let's do it as a tree. Okay? Because then once I got my tree down, I've got every option sitting right there in front of me. So, in every box of 50 potato chip bags, 2 of them are underweight. When I pick the first one, okay, so let's call it bag 1. Either I get an underweight or I don't. I gotta make this bigger. Let's call it a good bag, okay? Or you could word that proper weight, maybe. I don't know. Good seems more reasonable. So, what's the probability of getting an underweight bag if this is the first one I'm picking? Yeah, 2 out of 50. Okay, what's the probability of getting a good bag? 48 out of 50. Okay, so far so good. But then I go and get the second bag. Now this is conditional as to what happened when you picked the first bag. So this branch Well, I could get an underweight twice. So given that I've already chosen an underweight bag, how many underweight bags are left in here?
149.
Yeah. Okay. There's one left, but I've already chosen one bag, so there's 49 bags left. Once I've already chosen an underweight bag, what's the likelihood of getting a good bag? I got 49 left. How many good ones are left if I've taken a bad one?
49.
I heard lots of different numbers. There's still 48. I haven't chosen a good bag out of there yet, right? We know there's 48 in there. Okay? Then, if I took a good one, well, maybe I'll get a good one. Well, let's be consistent. Underweight is on top. So underweight, well, how many are still left in there if I took a good one? There's still 2 in there. But there's now 49 bags because I've already took one bag. And the only other option is I can get a good one and then another good one. Well, if I pulled out a good one, I'm down to 47 good ones left, right? Because there was 48. And, of course, there's 49 bags because I've already pulled a bag out. Okay? Then what? What's the likelihood of this happening, then this happening? Multiply them together. Okay? Like I say, there's lots of ways to do that. That's probably the most common sense way would be 2/50th times 1/49th is, what the heck does that thing say? 4 zeros in front of that 8. Or sorry, 3 zeros in front of the 8. Move the decimal 4 spots to the left, right? That says 8.16 times 10 to the minus 4. So if the decimal's there, for those of you who haven't taken like chemistry, 1, 2, 3, 4 spots. That's what that says. Okay? In other words, it's pretty small, isn't it? You have to be pretty unlucky to get both of those 2 bags from that 50, right? Okay, how about 2/50ths times 48/49ths? 0.0392. .48 50ths times 2/49ths is, hey, isn't that the same number? 0.392. Is that any shock? Would we expect that? Is the likelihood of getting a bad one then a good one, should that be the same as getting a good one then a bad one? Yeah. Okay, and then finally, well, it's pretty likely that you're going to get 2 good ones, because that's a lot more probable, right? Because there's a lot more good ones than bad ones. So this should be the bulk of what happens. Like I say, you must be really, really unlucky to get the 2 bad ones. That's 0.9208 for 4 decimals. So what should you do here? What should this all add up to? Yeah, but there is some rounding here. So here it's not going to be exact, but it better be close. That plus 0.0392, 2 of them. Okay, let's times that by 2. And then plus this puny guy, which won't really make that much difference. Should be pretty close to, whatever, it doesn't matter, 1. It is. Okay? If you're getting something like 93, well, that's way off. It better be close to 1. The more you round, the less it's going to be away from it, right? But we don't want to worry about 12 decimal places here or anything, okay? I'm pretty sure I got it all. That's 100%. Okay? Well, A, determine the probability both are underweight. There it is. As a percent, move it back 2 spots. That's 0.08% of the time. So quite unlikely that will happen. Determine the probability neither are underweight. There it is. 92% of the time. Okay? And then one is and one isn't. What do I want to do? Is it 0.0392? Or is it 0.0392? Or do I want to add them? Because isn't this the same path? I got one good one and I got one bad one. Either way you get here, okay? I want to add those together. Okay? Only one is underweight, add. So that's 0.0392 times 2. There's 2 ways that'll happen. 0.0794. Is that 9 or 8? 8. Yeah, that's one. I said 9. I saw 8. Or 7.8% of the time. Okay? You'll get a bad one and a good one. Okay? One more. Another tree example. Because this is different than the one we got yesterday, and just because of a couple of words. Mr. Watson's old man doesn't like golfing in the rain. Well, most people don't. He has an 80% chance of golfing poorly when it rains. And I don't want a period there. 35% chance of golfing poorly when it is sunny. So obviously he wants to golf when it's sunny because he does better. Not to mention that it's more enjoyable. There is a 45% chance of rain tomorrow. What is the probability that he will golf poorly, with 2 O's, tomorrow? So you don't know why this question's different than the one I gave you yesterday with hash and our calculator, okay? But I'll point it out when we're done. First, do I want to start here? Don't write this. So, chance of golfing poorly when it rains. What do I write? Poorly rain. Don't write this. Okay, 0.8. that means what? 0.2 of what? Not rain or not golfing poorly? What does this say? That's conditional, isn't it? He golfs poorly if it rains. So I can't put this first because this is conditional upon this. I have to start with that. I want to start with the rain. Okay? That determines whether he golfs poorly or not. So this is not even worded in the right order. Here's where I want to start. Does that make sense? It depends on the rain. If it's raining, he doesn't golf well. If it doesn't rain, well, I guess that means he does golf well. Okay? This depends upon the rain, so that's where I want to start. Okay? 45% chance of rain. So rain, 0.5. Okay, so not rain means sunny, according to this question. Yes, this is what you want to do. That's where we got to start. Okay, I just wanted to point that out. Don't just assume we start where the first number goes first. Okay. Then, if it's raining, what's the likelihood that he's going to golf poorly? 80% chance of golfing poorly when it rains. It's raining, so that's 0.8. That means he golfs, what do I say, not poorly, or golfs well, or however you want to word it. There's still a 20% chance he'll golf well if it's raining, right? And then the other side of my tree, if it's sunny, well, that's got to be poorly or golfing well or not poorly. 35% chance of golfing poorly when it's sunny. Sunny, poorly, 0.35. Therefore, he'll golf well when it's sunny 65% of the time. Okay? Does that make sense? All right, multiply it out, and then the rest should be easy. Just answer what it asks. 0.45 times 0.8, or if it's just one question, maybe you just want to do one branch. Which branch do we want here? Let's just multiply it out. 0.45 times 0.2, that's 0.09. 0.55 times 0.35 is 0.1925. That's not big enough to round, so don't round it. 0.55 times 0.65, 0.3575. Look like it add up to 100? Trust me, it does, but you should check it. Okay. What's the probability he will golf poorly tomorrow? Yesterday we had to take a little ratio of something. This is different. All it says is, what's the probability he will golf poorly? He'll golf poorly. There's a poorly. There's a poorly. We just add them together. And I'll tell you why that's different than yesterday's. %55 probability he's going to golf poorly because it's going to rain. Yesterday's question was worded in the form he golfed poorly, period. What is the probability it rained? Okay? That's conditional. It's telling you something happened. He golfed poorly, period. So I know that's there, I know that's there. What's the probability that it rained? So I want this divided by the total of these. That's all I can do is say it, right? It's hard to explain. This just says, what's the probability he will golf poorly? This plus this. Okay, yesterday's wording was a little different. I know that's kind of tricky. So if that's what it said, this is what you would do. 0.36 divided by 0.36 plus 0.1925. Okay? Which is something different than 55%. I didn't work it out. Okay? So hopefully that kind of makes sense. I don't know what the exam questions will look like because I haven't looked at it yet. But just try to go back and forth, look at the wording, try to make sense of the difference. Okay? Just going to add a couple more here.